Well, am I reflected right now? Is that is that or am I falling? Okay. I am reflected. I am upside down because today we're going to be talking about reflections, translations, rotations, and dilations. But first, the module 4 review. I hope you're ready. It's time. Okay, just making sure everybody can hear me. Okay, we're good. So module 4 has already come to an end. These things are happening quicker than I'm used to because we have short chapters, but that's okay. Okay. The first thing you need to do for module 4 is flashcards. Okay, so we have a lot of vocabulary, and so the tried and true method that's been done for hundreds of years are flashcards. So we have exterior angles, remote interior angles, transversals, and alternate interior angles. We should add to this corresponding angles, alternate exterior angles, same side interior angles, right? We should also add that we talked about vertical angles in class. We talked about adjacent angles, and I'm going to use the angle symbol. We talked about linear pairs, which are special adjacent angles that form a line like this. These two adjacent angles, 1 and 2, form a straight line at the bottom there. Let me zoom in here a little bit. Oh, goodness. Okay. That help? There, you can see my linear pairs there. So we have the triangle sum theorem. Triangle sum theorem. Anything we've done is there. So some of the vocabulary I see here, but I, as you can see, have thought about many more. So it's your job to look back through the notes that we've taken this week in class and on the video here and come up with all the flashcards you can so you know every vocabulary word from after the Pythagorean theorem. Okay, so I didn't want to do every problem on this review because I do want to spend a lot of time on transformations, but this one right here I thought was a really good one. So we see that in triangle JAL, J is congruent to L. So I'm even gonna put little markings in here. So, and what is the measure of L? So actually, we should probably use my notebook because that's what you're using, right? So here we have two congruent angles. So angle J is congruent, which means same size, same shape to angle L, even if in my picture it does look like angle L is a little bit bigger, but that's only because I didn't do the best job of drawing it. When you see these markings, that means, okay, we are going to consider they are the same. And the question, what is the measure of angle L? And I want to show you the abbreviation as usual for the measure of angle L. You would write in M, the angle symbol, in L. That means the measure of angle L. You can just write that, okay? So that's what they want to know. And so we know we have 67.8 degrees is our exterior angle here. And we have a linear pair. We have a line right here, and we have two adjacent angles that form that line. So we're going to call this X because we don't know what it is. So let's go ahead and find, and then we also know this is a K up here, right? So the measure of this angle right here near vertex K is X, and the exterior angle is 67.8, but together they form a line. So we can set up the equation 67.8 plus X, these two angles put together equal a straight line, and we know that that is 180. So now to solve for X, we can just subtract 67. Oh, 1 second. All right, so subtract 67.8 from that side and from this side. Notice that I have a decimal place here, so I have to put a decimal point up here and add a 0. A lot of people miss that. All right, you forget those those fifth grade, routines there, lining up your decimal places. So now I'll just use the calculator since it's here. Minus 67.8, 112.2. 112.2 degrees is X. So now I'll go back up to my triangle and I'll write 112.2. And guess what? We need to know the measure of angle L, right? And that's going to be hard because we don't know either measure, but we know they're the same. So we could, and we already used the letter X, so maybe I'll use the letter Y. So whatever they are, they're the same. So I can just put the same letter in both of them, okay, because they're the same. And now I can set up my triangle sum theorem because I know the three angles in a triangle they also add to 180, right? So this is like step one, and this is the linear pair because they were a linear pair. And now step two is going to be the triangle sum theorem. So y plus, let me write it like this, angle J plus angle L. I should use my new abbreviation. The measure of angle J plus the measure of angle L plus the measure of angle K equals 180. That's the triangle sum theorem, right? Okay, and we know that the measure of angle J is y. The measure of angle L is also y. The measure of angle K is 112.2, and they all add to 180. Now I'm gonna solve this. So y plus y is 2y. And so that's all I'm gonna do for that step is combine the y's, combine like terms, as we say in math. And now I'm going to solve a two-step equation. So I'm going to take and subtract. I'm going to not anything there and subtract on this side. 180 minus 112.2 is 67.8. 2y equals 67.8. Now I'm just going to divide by 2 to get y by itself. And 67.8 divided by 2 is 33.9. 33.9. And remembering that's degrees, right? So this is 33.9 degrees. And so is this 33.9 degrees. And of course, if I check, I should see that all three of these add to 180. So let's make sure. 33.9 plus 33.9 equals plus 112.2. Look at that, 180 on the dot. Very good. All right, and I want to do, and we can do this one in class, is a great one. But I want to do one more. Because I have this problem right here, okay? So let's read it and then we'll write it in our notes. In the figure, line L, I told you they used lowercase parallel to talk about lines, is parallel to line M. Select all true statements about the figure. Okay, so we are going to draw this in our notes. Pause the video. All right, there we go. And this is line L, M. And the first thing I see when I see this is I want to recall my vertical angles in linear pairs. So right here, vertical angles would be like 1 and 2. 1 is congruent to 2, but also 3 and 4, even side to side, those are considered vertical angles too. So angle 3 is congruent to angle 4. In linear pairs, we need to know about linear pairs. So again, 1 and 2. So two angles, two adjacent angles whose non-common sides form a line. And these are supplementary. That means they add to 180 degrees, okay? Supplementary. So let's use those two concepts along with the fact that the lines are parallel to try to figure out every other angle measure. So if this is 61, this angle up here is vertical, and we know that vertical angles are congruent, right? So that means that this is 61. And if this is a straight line right here, and I know F is vertical with this one, so what's that one? Well, if this is a straight line, then 61, this angle, and 54 add to 180. So I could do a little math right there. 180 minus 61, 119 minus 54, 65. That would have to be 65 so that the three of them add to 180 because the three of them together make a straight line. So if this is 65, then this must be 65 because they're vertical angles. All right, so I'm circling our answers now. Now we have two angles in, well, we have these two angles down here. So what are those? Well, if you look, 54 is a corresponding angle with this angle. So this must be 54 as well. That's corresponding. We'll talk about that in class tomorrow. And so now we can find out this angle and we can find out that angle. So now right here we have a linear pair, right? So let's subtract from 180. Well, 180 minus 54 is 126. So that means this must be 126. And because we have a linear pair. And then here, we can use the triangle sums theorem to figure out that one, right? Because 54, 61, and this have to add to 180. So let's start with 180. And we'll subtract 61. And we'll subtract 54. And we get 65. Do you know what? I see that's the, oh, anyway. Okay, so that's 65. So then that means that this is 65 because these are vertical angles. All right, so now let's see what we can answer is G54. No, G is not 54. Sorry. H is 126. Yeah, H is 126. F equals G. F is 65. G is 65. Yes, that's true. G plus H equals 180. Let's see. G is 65. H is 126. Okay, 65 plus 126 equals 191. So no, that's not true. F equals H. F does not equal H. Okay. So you see, in order to answer all these questions over here, I just used vertical angles, linear pairs, and one corresponding angle pair. They're in the same top right corner of the intersections of two parallel lines cut by a transversal. And so I knew they were both 54. And everything else was either a vertical angle or a linear pair. Isn't that great? All right, so that's a little bit of module 4 review. Now we're going to head on over to the beginning of the book, because now we're going to talk about transformations. Okay, transformations and congruence. Ooh, treasure hunt. That sounds fun. Okay, so let's talk about spark your learning. So we're going to look at, I can describe what happens to the sides and angles of a figure when it is transformed. Okay, so we're going to talk about that. Sides and angles of a figure when it's transformed. So let's write down investigating transformations. So I'm going to give you a few notes, and then we are going to answer the questions that they've asked us in the book. So what I want everybody to do is I want you to find something like, here I have this little pencil. This was holding these pencils, okay? And now I'm just going to cut it to make my awesome right triangle. Actually, I want to get a right triangle that is a little bit more scalene. So you can cut anything you want. Okay, so I have this figure here. This is going to be my triangle. And once you have your triangle, it doesn't have to be exactly like mine, but get something, some sort of a triangle, and draw it onto your paper. Sketch it onto the paper by tracing the sides. Okay, and then we'll label it A, B, C. And now we're going to talk about the transformations that we have. So let's write down our 4 transformations. We have translations. We have reflections. We have rotations and dilations. I'm going to teach you this little wave right here. Oh my goodness, I'm still upside down. Perhaps I should go right side up. Okay. All right. Oh, so here's my hand, right? So we are going to do a translation wave. So put your hand up and then go, and then just move it to the side like this. This is translation. Hello, how are you? Okay, I'm translating. I'm just moving my hand. I'm not rotating it. I can move it up and down. I can move it side to side, and I can even move it diagonally. Now I'm going to reflect. So I'm going to flip, 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 flip. Same hand, just flipped, right? That's a reflection. Okay. And then I'm going to rotate. So rotation is like this, where you turn your hand so you can say, hello, Mr. Field. You can rotate, you can reflect. Hello, Mr. Field, how are you? And then you can do, and then the last one is a dilation. That's a kind of weird. That'd be a size change. So it'd be like this. Hello, Mr. Field. Okay, so recapping, translation. Hello, Mr. Field, like washing a window. Reflection, it's like the model wave. Hello, Mr. Field. Rotation is kind of a weird wave. Hello, Mr. Field. Or maybe like waving goodbye. And then the weird one is dilation wave. when you shrink your hand. Hello, Mr. Field. Okay, there we go. So that's the waves. So now back to our triangle. So we are going to take our triangle, and the first thing we're going to do is just translate it. So move it down on the page, but do not turn it. No turns allowed for the translations. Just gonna go straight down like this. So B, A, C, and then we can write, this is a translation. Moved or shifted. It's all that happens in a translation. Notice you can take a pair of corresponding vertices, A and O. We always, in our new figure, we write a prime symbol. This is called a prime. Okay, and in our original shape, that is called the pre-image. And when we move our shape, that is called the image. Okay, so when we're talking about transformations, we're transforming something. We're going from a pre-image, which is before, to an image, which is after. You can think about those movies when the person gets a makeover and then all of a sudden they're like the most popular kid in school until it all comes unraveled, you know? Okay, so now that's the translation. So this first one, let's label this translation. Translation. Next, let's look at a rotation, at a reflection. So now I'm going to start over here. Tracing my triangle again. Okay. And now I'm going to take this triangle and I'm going to reflect it. I'm going to flip it over. Okay. It's not allowed to be turned at all. So let's say that this is A, B, C, and now A prime is right there. C prime is right here, and B prime is here. So this is a reflection. And I want you to notice something that we're going to introduce the marking for congruent angles and congruent sides. In our translation, angle A is congruent to itself, so we make a little marking. Angle B is congruent to itself, make a little two markings. And angle C is a right angle, right? All right. Is it still true that they're congruent angles? Yes. Angle A is congruent to angle A prime. Angle C is congruent to angle C prime, even with the reflection. And angle B and B prime are still both right angles. And if I measure, well, I used to have a ruler around here, but we can measure and we will see, let's say this is 4 inches. AC is 4 inches. Is A prime, C prime the same length? Yeah, it is. Let's call this 3 inches. Then C prime, B prime would also be 3 inches. And we know in a right triangle, 3, 4, 5 is a Pythagorean triple. So let's just call that that. Same thing here. We have 3s on the bottom, 4s on the side, and 5. Okay, so we can see all the side lengths and all the angles are congruent. And we still have space on our paper for one more translation. I mean transformation, and that is gonna be a rotation. So let's start, draw a triangle here. Okay. A, B, C, my triangle. And now if I want to rotate this triangle, I can rotate it around a certain point. So let's just rotate it like that. And now to rotate my paper to figure out that this is A, B, C. A little bit more difficult, but it can be done. Okay, so you can see how that is turned, right? So we have A. You see now, you can see why our corresponding angles are important to identify, because now they're all over the place. It's a bit stressful, but once we label them, then it helps us. So I just put my markings, and then I know that this is 5, 4, and 3, and this is 5, 4, and 3. Okay, and so this is a rotation. We're going to look in detail at each transformation later, but this week is about an overview. So we're just looking at what are they. And the last one is dilation. And a dilation is going to take this triangle and it's going to make a similar triangle, which we learned about in this week's lesson. So if we take this triangle, and so I'm just going to sketch this one the best I can. So here's A prime, B prime, C prime, our image. There's our pre-image. Here's our image. Okay, much smaller. This is called a shrink. Okay, but we could also have, another pre-image that is, could have an enlargement. If image is greater than pre-image. So there's two types of dilations. There's shrinks and there's enlargements, right? I don't want to say stretch because a stretch wouldn't be similar. It would be a different shape. So it's when, and then we'll talk more about that. You know, they are dilated by a scale factor. But for this week, we're just going to say that even though we have different sizes and our side lengths are different, we know that the angles are still congruent. But the side lengths they are not congruent, but they are proportional. So let's write that down. Angles are congruent. Side lengths are proportional, which means they all have the same ratio. Okay, so for example, let's just say that instead of 3, 4, 5, I call this 8, 6, 10. Okay, and then I call this one 3, 4, 5. So if that's the case, this will work. These side lengths are all proportional. And I'm going to show you the example of what that means. I can take any corresponding side pair and make a ratio. So B prime C prime over BC would be 3/6, which we know is 1/2. If I take a different pair, like the vertical ones, A prime C prime and A prime B prime and AB, and I divide those, A prime B prime is 4, AB is 8. Guess what that reduces to? It also reduces to 1/2. See? Even though we started out with different numbers, we end up with the same ratio. And I know what you're all thinking, but what about side AC? Oh yeah, it works. Look, 5/10. 5/10 also reduces to 1/2, right? A prime C prime over AC works as well. All side lengths have the same ratio. All right, let's just take a gander at some of the questions, and then we're gonna call it a day for this video. On graph paper, draw a quadrilateral that has exactly one pair of parallel sides. Remember, parallel sides are sides that would not intersect even if extended indefinitely. Cut out that shape and trace it in the center of the box. Okay, so let's just look at our definition. A transformation is a change in the position of a figure. So let's write down that definition at the beginning. We did a lot of good transformation. What is it? A change in the position of a figure. A change in the position of a figure. All right, there we go. There's the precise textbook definition. But you can see, what do we want to do? Slide the quadrilateral. So what would that be? That would be a translation. So we can do that in class. And now use a ruler to measure the sides. We know they're going to be the same. A protractor to measure the angles. We know they'll be the same as well. So that it says what happened? Well, they're all congruent, right? When you slid the shape, did anything change besides the position? No. Draw a horizontal line near but outside and flip. This, when they flip it, that's going to be a reflection. Okay, and I wonder if they're going to talk about a rotation next. Draw a polygon, 6 sides, cut out the Okay. So you can see, what are we doing in this section? We're taking shapes just like my triangle, and we are practicing our translations, our reflections, our rotations, and perhaps even our dilations. As we go on into the book, we will be going into all of those independently. Let's just look at one more question and then we'll be done. Tariq is working on a photo album and moved a photo as shown. What transformation did he use? Okay. So here's the before, a pre-image. Here's the after image. And it looks like I see this little piece up here, and then I see a little piece over there. So I think it's a rotation because I don't see the flower moved, but I do see the flower turned. Okay, so here this asking what happens to the angles. And then when we talk about rotations, we'll talk about clockwise and counterclockwise in class. And actually, let's just add that to our, okay. Last thing we'll add, sorry guys. I wanted to look in the book to see if I forgot anything. So rotations can be clockwise when we go around this way, or they can be counterclockwise. If you look at the clock and you go in the other direction, and clockwise is usually a negative degree measure, and counterclockwise is usually a positive degree measure. But more on that when we talk about rotations in particular. And this week is just about identifying, is it a translation, a reflection, a rotation, or a dilation? All right, great job sticking with me, guys. I will see you in class.